Hey, what's going on, guys? Let's see how we can find out whether this series converges or diverges using ratio test for series. So in order to do ratio test, what we do, we take the limit n approaches infinity and then we take an plus 1 divided by an absolute value and see whether we get less than 1. If it's less than 1, it converges. If it's greater than 1, it diverges. If it's equal to 1, no conclusion, so we have to do something else. Here let's apply this one here. So limit n approaches infinity, and this an plus 1 is basically mean we add 1 wherever we have n. So here we have n in this one, so this is going to be n plus 1 power, we have n again, so this is going to be n plus 1, and in the denominator we are going to have 1 plus and 3, and also we have n right here, so this is going to be 3 times n plus 1. So this is how it's going to be. Then we divide this one by an, that's going to be the original function. So instead of dividing, what we can do, we can multiply the reciprocal of this one. So it's same as dividing by this one, right? So the reciprocal of this one is going to be 3 power 1 plus 3n divided by n power n, and this is going to be the reciprocal of this function. And let's see what we get from this one. So here we can, this one we can separate it into two parts, like limits n approaches infinity, absolute value n plus 1 times n plus 1 times 1. So I just expanded this one. This is same as this one, right? When we multiply, the powers will add, and when we divide, the powers will subtract. So here the powers are adding, so this means multiplication. And in the denominator we can expand this one. This is going to be 3 power 1 plus 3n plus 1, right? And in the other side we have 3 power 1 plus 3n over n power n. And if you notice, we have 3 power 1 plus 3n, 3 power 1 plus 3n. So this basically means 3 power 1 times 3 power 3n times 3 power 1. So this is same as this one. So what we can do, we can cancel these two terms, and we are only left with 3 power 1. And here let's see what we can do from this one right here. So this one, let's rearrange these things. So let's continue this one right here. So this is going to be limit n approaches infinity. We have, actually this one we are multiplying both by 3, so this 3 cube actually, right? 3 cube, because we multiply 3 times n, so 3n, 3 times 1, 3. So this should be 3. This 1 plus 3n cancelled already, we have left with 3 cube. And let's simplify and see what we get. So here we are going to have 1 over 3 cube times n plus 1 power n times n plus 1, right? So instead of writing n plus 1 right there, so before I do that, you know what I can do? I can take this 1 over 3 cube in front. So this is going to be, so that way everything becomes easier. So here we are going to have 1 over 3 cube is 27, and if we take that one, we are only going to have n plus 1 power n times n plus 1 power 1, right? And then n power n. Now we can separate this one into two parts. 1 over 27 limit n approaches infinity, n plus 1 power n power n times limit n approaches infinity, n plus 1 over 1, right? Maybe before I do this one, I show this one right here and do this in next part. That's why it becomes less confusing, right? So here what I did was, we can separate this one like this, n plus 1 over 1. If you multiply these things, you will get the same answer, same thing like the one above, right? So here what we can do, we can separate this one into, we can find the limit separately, so that way everything becomes easier. So this is going to be 1 over 27 limit n approaches infinity, n plus 1 power n over n plus n times limit n plus 1 over 1. This also n approaches infinity. So here this is 1 over 27, that doesn't change anything. Limit n approaches infinity, n plus 1 power n over n power n. And if you see something like that, this is basically e. This is something you should remember, because yeah, that's the way it is, right? So whenever you have something like this, that is e. If you remember this, this will become much easier. So this is e, and then limit n approaches infinity, and if you substitute infinity for this n value, that's going to be infinity. So this is going to be multiplied by infinity. The answer is going to be infinity. So this is greater than 1. So we know that if it's less than 1, it's convergent. If it's equal to 1, no conclusion. If it's greater than 1, it's divergent. So this is divergent series. So we can go ahead and say this is a divergent series. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.